Okay, we have a method to help us solve triangles when the triangle is not a right triangle. And let's put my triangle on here. So I have angle A, angle B, angle C, and our sides are still opposite. We're going to use lowercase letters. So the opposite angles and sides use the same letters. Now the law of cosines starts with looking like the Pythagorean theorem. C squared is equal to A squared plus B squared. But if it's not a right triangle, this is not going to be true. So we subtract 2 times AB times cosine of C. And what you may notice is that the side in the beginning and the angle at the end have the matching letter. And it's also true for the other two sides. So we can rephrase this and go B squared is equal to A squared plus C squared minus 2AC, and then cosine of the opposite angle. And the same is true for the last one. B squared plus C squared minus 2BC cosine A. And this is the formula we can use to solve triangles even if they're not a right triangle. So for our first example, I'm going to begin by drawing a triangle. It doesn't matter if it's to scale or not. I have angle A, B, and C. So I'm going to be side B right here, and side C is 14, and angle A, so if this is side B, this is angle B, and this is that's angle B. Angle C, so this one, angle is 54, angle A, and we want to find angle A. So it helps when we know the angle opposite the side that we're looking for. So we're going to use the formula that is equal to A squared. So that means B squared plus C squared minus 2BC cosine A. And so we're going to just substitute in. So B is 10, so that squared is 100. I'm going to square 14, and that's 196. And then 2 times B times C, so those two sides multiplied together are 140. And then cosine 54. So I'm going to simplify a little bit, add these two numbers together, multiply 2 and 140. Now one thing that we are not going to do is we are not going to subtract these two numbers because this 280 is multiplied to cosine 54. 280 times cosine 54 is a number. So we cannot subtract 296 and 280. So resist that temptation. So when you plug all of this into your calculator, you get 131.4261. Sorry, that's a 0. 4201. And then we're going to take the square root of that, and this gives us a side of 11.5, and you can just round these answers to one decimal place. Let's try. Okay, so for our next triangle, it always helps me to draw the triangle. So I'm going to draw the triangle. Put side A right here, so that means this is going to be B, and this is C. And I want to replace those with numbers, so I'm going to replace side A with 30, and I'm going to replace side C with 37, and this is right here is angle B. So we're going to use law of cosines that begins with B squared. Remember, it starts out looking like the Pythagorean theorem. And I keep having rightos. Let me erase that part. So I just replace that. There's my C. Okay, so let's substitute in. So we have 30 squared plus 37 squared minus 2 times 30 times 37 times cosine of the angle. You put this all into your calculator all at the same time. Be careful with your parentheses. You're going to get 2,753.228, and then B will end up being 52.5 when you take the square root. Okay, so let's solve this triangle. What you may notice is that we know all three sides. So we're going to be finding an angle. So I'm going to label these. And angle A is opposite side A. Now we're going to use the formula that has the cosine of A in it. So which means we're going to begin with the one that has A in the beginning. Use this one. So we're going to end up having to inverse a cosine in order to get the angle out. So let's start substituting what we know. We know that A is 14, and that B is 15, C is 18. So we're just going to substitute, put everything into place, and square these, and you'll square 15 and 18 and add those together for 549, and then you'll multiply 2, 15, and 18. That gives you 540. Now remember, 540 is multiplied to cosine A, so you cannot subtract 540 and 549, but you can subtract 549 from the other side, so that will give me 353. Like that. And you can also divide negative 540 on both sides. So that will cancel there, and the negatives cancel. And then to get the angle out of the cosine, we're going to inverse both sides. So we have cosine inverse of that fraction, and you can enter that whole thing into your calculator just like that. When you do that and round to one decimal place, you'll get an angle of 49.2 degrees. Okay, we're going to apply this to a word problem. Now, a surveyor sets out stakes at extreme ends U and V of a property line. So we'll say this is our property line. Here's U and V. And a point W is located such that UW, so we'll put W down here. And it says that UW is 800 and VW is 500, and this angle between them is 102, and we want to know the distance from U to V. So if we use the same format of opposite sides are the same letter, I'm going to use a small w right here. And it doesn't matter what the letters are. What matters is how we use them in our formula. Like this. What matters is that the first variable is the angle opposite the angle we're going to be using. And we're going to be using angle W. So let's make some substitutions. So we've got W squared, and then we'll have 800 squared, 500 squared, minus 2 times 800 times 500 times cosine of 102. And this is going to give us some pretty large numbers. So when we square 800 and square 500 and add those together, we're going to get 890,000. And when we multiply 800 and 500 and double it, then we get 800,000. Pretty big numbers. And then we're going to multiply that by cosine of 102. So we can put this whole thing in the calculator all at the same time, and we'll get this number. So it looks like that's 1,056,329. But we're going to take the square root of that because that's w squared. And the number that it gives us is 1,027.8 meters. That appears to be a pretty reasonable number.